sum of subsequence widths. The width of a sequence is the difference between the maximum and minimum elements in the sequence. So for example, if we have a sequence of 2 and 3, so the width is just 2 minus 3 minus 2, so it is 1. So for 1 and 3, the width is 2. We need to return the sum of all the widths of the subsequence, and we need to have a modular of 10 to the power of 9 plus 7. Yeah. So we need to return the sum of widths of all the non-empty subsequence. It must be non-empty. A subsequence, we need to know about that. So here is an example. And if you solve a lot of a subsequence problem, you need to know what is the definition of a subsequence. Now let's just get started for the problem. Yeah, I'm going to use an example of like 1, 2, 2, 3 as an example for this problem. Yeah. So first of all, if we check one by one, it's going to be really difficult. If we use the brute force, we have to check all the subsequence. Yeah, so we can use the 2 for loops to get all the subsequence, and then we're going to check the minimum and maximum value. It's going to be at least O(n) squared time, and n is 10 to the power of 5, so this means the brute force is not possible. We have to use some clever ways to solve the problem. Yeah, so yeah, we can sort the array first. Why we can sort it? Because if we sort the array, we know which element is the minimum value. So for example, if we sort the array in increasing order, if we loop through the first element, we should know about this element must be the minimum element. Yeah, and definitely we also know the maximum element inside of the array, it should be 3. And if we loop through this 2, we should know about that. What is how many yeah, if we loop through the array, for example, yeah, let me explain it again. If we loop through the sorted array, for example, yeah, we need to check how many minimum elements at its left side and how many maximum elements with how many minimum elements which is 1 at its left side, and how many maximum elements which is also 1 at its right side. Yeah. Why we should solve it like this? Because this just makes the problem, we are not solving the problem one by one, we just solve the problem as a whole problem. Yeah, so for the whole problem, for the first element 1, we need to check how many we need to check what is how many what is the minimum, what if the minimum element is 1, and how many subarrays. Yeah, so if the minimum element is 1, how many subarrays? It's just at its right side. So from its right side there are 3 elements, and for each of the element we can choose it and not choose it. And how many ways? 2 ways, and 2 ways, and 2 ways. Yeah, so if the minimum element is 1, so there are 2 to the power of 3 ways. Yeah, so for 1, if the maximum, so here I'm gonna use a max, and this is minimum. Yeah, if the maximum element is 1, and how many of them? Currently we just need to check this 1 at its left side, so there's no element. Yeah, but we have to choose this 1. So how many of them? It is 1. It is 2 to the power of 0. Yeah. Now we are going to check the second element, this 2. Yeah. So what if the 2 is the minimum element, and how many of them? If the 2 is the minimum element, we can check from its right side. For this 2, we can choose it and not choose it. And similarly for the 3, we can choose it and not choose it. So if it is 2, yeah, the minimum element gonna be 2 to the power of 2. And what's gonna be the maximum element? And we're gonna check from its right left side. So we can choose this one or not choose this one, but this 2 definitely we're gonna choose. So it is 2 to the power of 1. Next, we're gonna check the next 2. Yeah, for the next 2, similarly, if this is the minimum element, it's gonna be 2 to the power of 1, and if it is the maximum element, its left side there are 2 elements, 1 and 2, so it is 2 to the power of 2. And similarly, we're gonna check this 3, And if this is the minimum element, how many of them? And it's gonna be 3 to the power of 0. And if this is the maximum element for this 3, and how many of them? 1, 2, 3, 2 to the power of 3. Yeah, because for each of the element at its left side, we can choose it or not choose it. So it is 3 to the power. It is 2 to the power of 3. Yeah. So for the last one, it is 2 to the power of 3. Yeah. Now, how can we solve the problem? Because according to the definition, the width is just the maximum element minus the minimum element. Yeah, so this means we're gonna get a maximum and minus the minimum. Yeah, so for the first one, it's gonna be 2 to the power of 0 minus the maximum for this one, 2 to the power of 3. And this is this is for this one, it appeared how many times? So finally, we're gonna use this result times 1. Yeah. So this just means, oh, there are 2 to the power of 3 cases of the element 1, which is the minimum. And for the maximum, it is 2 to the power of 0. So we're gonna use the maximum time minus the minimum times, and times 1. This is just how many times it appeared. And we're gonna check all of them. So next, it's gonna be 2 to the power of 1 minus 2 to the power of 2 times 2. Yeah, and next it's gonna be 2 to the power of 2 minus 2 to the power of here gonna be 2 to the power of 2, 2 to the power of 1 times 2. Yeah, for the last one, it's gonna be 2 to the power of 3. Here it's gonna be the how many, if 3 is the maximum element, how many subarrays? It is 2 to the power of 3. And if 3 is the minimum element, how many subarrays? 2 to the power of 0. And we just need to times this 3. And finally, we just need to sum of all of the result. It's gonna be the final result. Yeah. Now let's just get back to the coding part. We're gonna prepare the length of the nums. As I said, the nums should be sorted in increasing order. And I'm gonna prepare a result, and similarly, I'm gonna prepare a mod 10 to the power of 9 plus 7. Now I just need to enumerate the nums. So for I, x in enumerate nums. Yeah, so the result should plus equal to the maximum. How many maximum element? If this element is x, we need to check how many maximum element at its left side. Yeah, let me just use the previous example, like 1, 2, 2, 1, 2, 2, 3. Yeah, so it's gonna be we're gonna use a power. So this is called quick power. If we use this one, it's gonna be really quick. We don't need to check the modular cases, because like 2 to the power of 100, it's gonna be a really big number. But we can use a library in Python. Just use the power library, it's gonna work. So 2 to the power of I, and with a mod, we just need to put the modular inside, and it's gonna work. Yeah. Now we need to check the minimum. If the minimum value is 1, what is it gonna be? 2 to the power of n minus 1 minus I. Yeah, let's just check the first element to check if it works. So n should be 4 minus 1, it is 3. 3 minus 0, it is 3. So it means at the right side there are 3 elements, 2 to the power of 3, and we need a modular. So this is gonna be really fast to calculate the modular. If to calculate the power, if the power is a really big number, we just need to put a mod inside, and then it just means the final result would be modular 10 to the power of 9 plus 7. Otherwise, you have to check for each of the time. It's gonna be a little bit hard, I think, for the power. If it is a big number, you have to calculate it. Yeah. Now you don't need to check the modular part. You just need to put modular inside. And finally, you just need to return this result modular the mod. Yeah, because this result may be bigger than this value, 10 to the power of 9 plus 7. Now let me just run it to check if it works. Yeah, let me just check why it doesn't work. I output a 0. Yeah, I need to time x. Yeah, I forgot about it. So it means how many times of if the maximum element is 1, and how many times if the minimum element of 1, and we need to time this 1 times the x, and similarly for others. Yeah. Now let me run it. As you can see, it works. Now let me submit it to check. Yeah, as you can see, it works and it's pretty fast. And let's just calculate the time complexity. As you can see here, this is just ON. Yeah, and here this is hard. Yeah, so this is ON time, but for here we need we used power, so 2 to the power of a number. Normally we're gonna say it's gonna be just 01 time. Yeah, basically if the number is big, it may be more than 01, but yeah, for analyzing the time complexity, we're gonna analyze the power as just 01 time. Yeah, so this power actually calculated uses some quick ways. It is not just like 2 times 2 times 2, like 32 or so. I think this power, normally while we analyzing this power, it may be log n time or it may be ON time. So I think ON time is okay for analyzing this kind of power. Yeah. So the final time complexity would be ON. Thank you for watching. See you next time.